Hi there students, and welcome to lesson 3 on this topic of quadratic equations and their graphs. Now in this lesson I want to discuss with you the possibilities that we have for the axes intercepts for the graphs of quadratic equations. And let's remember from lessons 1 and 2, the graphs of quadratic equations are always smooth curves called parabola curves or parabola graphs. I've already drawn some on the board. That curve there is a parabola curve. That curve there is a parabola curve. That curve there is a parabola curve. Now, when we draw graphs of equations, we draw graphs of equations on a set of xy axes. Okay? The horizontal axis is the x-axis. The vertical axis is the y-axis. Now, what do we mean by the axes intercepts? Well, the x-intercepts for the graph of an equation are the points where the graph cuts through or touches the x-axis or the horizontal axis. The y-intercept or y-intercepts for the graph of an equation are the points where the graph cuts through the y-axis being the vertical axis. So the x-intercepts for the graph of an equation are the points where the graph cuts through the horizontal axis or through the x-axis. The y-intercept or the y-intercepts for the graph of an equation are the values where the graph cuts through the vertical axis or through the y-axis. Now, depending on where the parabola graph, or depending on where the graph of the quadratic equation is positioned on the xy plane, and when we draw a set of xy axes, we create a flat surface called an xy plane or a Cartesian plane. Now, depending on where the graph of the quadratic equation or where the parabola graph is positioned on the xy plane, there are three possibilities for the number of x-intercepts that graph can have. Let's have a look at what I have on the board. So there are three possibilities for the number of x-intercepts that the graph of a quadratic equation, that is a parabola graph, can have. Let's have a look at what I have on the board. The first possibility is possibility A. Some quadratic equation graphs or some parabola curves have no x-intercepts. In other words, they don't touch or cut through the x-axis or through the horizontal axis at all. I've drawn two examples here. This parabola curve here has a turning point right there. It doesn't touch the x-axis. This horizontal black line here I've labelled with x, that's the x-axis. This parabola curve here doesn't touch the x-axis at all. It has no x-intercepts. Likewise, this parabola curve I've drawn here, this one's an inverted parabola, it turns around right there. So it heads up towards the x-axis, but it has a turning point right there, and at the turning point it starts to go back down again. So this parabola curve here doesn't touch the x-axis at all. So these two parabola curves have no x-intercepts. So that's the first possibility. That is the first possibility for the number of x-intercepts that a quadratic equation graph or a parabola graph can have. Some of them have no x-intercepts. In other words, they don't touch or cut through the x-axis at all. The second possibility is possibility B. Some parabola graphs or some quadratic equation graphs have only one x-intercept. Okay, some have only one x-intercept. And the quadratic equation graphs that have only one x-intercept are parabola curves or parabola graphs whose turning point is right on the x-axis. Alright, so some parabolic graphs have their turning point right on the x-axis. An example is this one here. This parabola curve, its turning point is right on the x-axis. So it just touches the x-axis at one point. So that's the turning point there for that parabola curve. It's right on the x-axis. So quadratic equation graphs whose turning point is right on the x-axis, they have only one x-intercept. I've drawn another example here. Here's an inverted parabola. It goes up towards the x-axis. When it touches the x-axis, it turns around and goes back down. The turning point for this parabola graph is right there on the x-axis. Alright, so again, this inverted parabola graph here has a turning point right on the x-axis. So that's the second possibility for the number of x-intercepts that the graph of a quadratic equation can have. Okay, some of them only have one x-intercept. Okay, and they are the ones where the graph just touches the x-intercept at the turning point of the parabola. Now, the third possibility, possibility C, some quadratic equation graphs cut through the x-axis at two positions. In other words, some of them have two x-intercepts. I've drawn two examples on the board. This upright parabola graph cuts through the x-axis there and there. Alright, so that upright parabola graph has two x-intercepts. Likewise, I've drawn an inverted parabola graph here. It goes up, cuts through the x-axis there, goes up to the turning point, which is above the x-axis, then it turns round and goes back down, so it cuts through the x-axis again there. Alright, so these two parabola graphs I've drawn there, they are examples of parabola graphs that have two x-intercepts. So, this is what you need to remember. When we're drawing graphs of quadratic equations, because of the shape of the graphs, they're smooth curves called parabolas, depending on where the parabola graph is positioned on the set of xy axes, or depending on where the parabola graph is positioned on the xy plane, there are three possibilities for the number of x-intercepts that the graph can have. The first possibility is some quadratic equation graphs have zero x-intercepts. They have no x-intercepts. The second possibility is some quadratic equation graphs have only one x-intercept, like these ones here. So possibility A is no x-intercepts. The second possibility, possibility B, is one x-intercept. The third possibility is some quadratic equation graphs have two x-intercepts. And they're the ones I've drawn here. Each of these two parabola graphs have two x-intercepts. Alright, so they're the possibilities for the number of x-intercepts. Some have zero x-intercepts, some have one x-intercept, some have two x-intercepts. Now, what about the y-intercept? The y-intercept for the graph of an equation is the value or values where the graph cuts through the vertical axis. The vertical axis being the y-axis. Now, for quadratic equation graphs, every single possible quadratic equation graph that you can draw will cut through the y-axis at just one point. Alright, so that's simple. Any, or that is all, quadratic equation graphs cut through the y-axis just at one point. And I've written that on the board. Y-intercept. All quadratic equation graphs, that is all parabolas, will have only one x-intercept. Well, will have only one y-intercept. Okay, that concludes lesson 3 on this topic of quadratic equations and their graphs. Thanks for watching. Stay tuned and look out for subsequent lessons on this topic of quadratic equations and their graphs. Thanks for watching. See you next time.